All right, Math 3, here's the benchmark review part 2. So, I actually stuck some stuff in from part 1 as well for those that either missed part 1 or feel like they want to make sure they know that stuff pretty well. So, first thing, converting degrees into radians and radians into degrees. Remember that on that unit circle, okay, halfway around the circle, or 180 degrees, is what we call pi. Okay, so they're the same. So that's what we use to convert. So the idea is that depending on what we need, we're either going to multiply by pi over 180 or 180 over pi. In the case of wanting the radian, it's pi over 180. So 20 times pi over 180, multiply across, we'd have 20 pi over 180, but we want to simplify. Okay, so we reduce 20 over 180. The zeros would cancel out. 2 over 18 would be 1 over 9, so we end up with pi over 9 as our answer. Number 2, same idea. Times by pi over 180. Okay, we end up with negative 345 pi over 180, because we typically want to leave the pi alone. So, if I think of 345, I know I can divide it by 5, right? So it would be negative 69 pi, and then 180 I could divide by 5, giving me 36. Looks like I could probably divide them both by 3. That would give me 12 and 23. And I don't think I can, and that would still be negative. I don't think we can reduce that anymore, so negative 23 pi over 12. Now, for 3 and 4, it's just the opposite. So I times by 180 over pi. Now, the pi's will cancel out, which is good. So then I just go 41 times 180, which is 7,380, divided by 36. And we end up with 205 degrees. Okay, number 4, same idea, times by 180 over pi. Again, the pi's cancel. 23 times 180 is 4140 over 36, and it's negative. So divide that by 36, and we get negative 115 degrees. And that's all there is to that part. Okay, now we're going to draw the angle in radians. Okay, so we may not be used to radians, but remember, the denominator, because half a circle equals pi, if we cut half of that circle into 8 pieces, then we're going to go to 7 of them. Okay, that's how we do it. So this would be cut in half. This would be cut into fourths. So I need to cut it into eighths. So cut those in half one more time. So then our angle would start right here and would go 1, 2, 3, 4, 5, 6, 7, and so it would go right here. So that's what 7 pi over 8 would look like. Okay, if I could erase the rest of this, it would look like that angle right there. Okay, now 5 pi over 2. So this one I cut in half. So there's 1, there's 2, but we're going to have to keep going around to get to 5. So there's 3, there's 4, and there's 5 again. So this one actually starts here, goes around once, and then comes up there. So it would look like that for 5 pi halves. And you could take these and turn them into degrees and graph it that way if you like to. The problem is when we get to 7 and 8. Now it's just 1 radian. Okay, so remember, pi, so half that circle is like 3.14. If we go half of that, or pi halves, that's like 1.57. Okay, so 1 would be about 2/3 of 1.57. So it'd probably be pretty close to right there. That's what my angle would look like at about 1 radian. Okay, remember 1 radian is that measure of the radius applied to that outside arc. Now 3, since pi is 3.14 radians, 3 would be starting here, going almost the complete length there. And that's what 3 radians would look like. So sometimes they can put the radians just in the decimal format. We generally don't like to do that, but sometimes we will. Now what we want to use is that unit circle. Okay, for these, we want to find the coordinates, okay, the sine and the cosine, right? Cosine is the x-coordinate, sine is the y-coordinate. So what we have are the unit circle or our table. So I could use this unit circle and say 180 degrees is right here. There's my coordinate. And so my coordinate is negative 1, 0. Okay. The other thing I could do is use my table right here and go to 180 and realize that the cosine, the x, is negative 1, the sine, the y, is 0. So either one works. For this, I would probably use this one, though. So the next up was 60 degrees. So 60 degree, or pi thirds, is 1/2 and square root of 3 over 2. So 1/2 square root of 3 over 2. Okay, now 11 pi sixths. So I look at 11 pi sixths, which is right here at 330 degrees, square root of 3 over 2, and negative 1/2. So square root of 3 over 2 and negative 1/2. Okay, number 12, 3 pi halves. So 3 pi halves is down here, 270. That's 0 and negative 1. Or 0 and negative 1. Then finally 3 pi fourths, which is right here at 135 degrees. So negative square root of 2 over 2 and square root of 2 over 2. So it looks like this. Okay? It's really all they want us to do on those ones. It's kind of just, do we understand that unit circle and where those pieces come in? Okay. Next up now is using that same idea to find the value. Okay. So if you recall, this is something we did in benchmark 1. So the sine is x over r, right? We make that triangle, the radius, be right here. The sine is the y over the radius. So we have to use the Pythagorean theorem to find the radius. So I take the x and the y, square them, add them, and that's going to give me the radius. So I have 16 plus 9. 16 plus 9 is 25. Take the square root of 25. My radius is 5. So for the sine, it's the y value 3 over the r value 5. So it would be 3/5. Okay. For the cosine, same idea. The only difference is we're dealing with the x. So cosine would be negative 7 over r. We just need to figure out what r is. So negative 7 squared plus 15, square root of 15 squared equals r squared. So 49 plus 15, because those cancel out, equals r squared. And that would give us 64. Take the square root of that. We get 8 for r. So it would be negative 7 over 8 for the cosine. Now the tangent is nice because tangent is just y over x. So a y value of negative 7, x value of negative square root of 15. Okay, negative over negative makes it positive. We would multiply by the square root of 15 over the square root of 15 because I don't like that square roots left there. I need to get 7 square roots of 15 over 15 for the tangent. So still a little ugly, but not too bad. Okay, then for the sine, okay, we need the r still. So we would go negative 6 squared plus negative square root of 13 squared equals r squared. So 36 plus 13, that would give us 49 equals r squared. Take the square root, and we get 7 equals r. So it would be negative square root of 13 over 7. Don't need to deal with that at all. Okay, now for the rest, all we simply need to do is look up on our table, and we could do it on our with our unit circle, but the table works better. So the tangent of 0 radians. So we want to go to this table here, and the tangent of 0, so we 0 radians here. Tangent is also 0, so we get 0. Cosine of 45 degrees, cosine of 30 degrees. We'll try to do 2 at a time, okay? So 30 degrees is here, cosine is square root of 3 over 2. 45 is here, square root of 2 over 2. So square root of 2 over 2 and square root of 3 over 2. Okay? Tangent of 90 degrees and tangent of 45 degrees. So tangent of 90 degrees is undefined and of 45 is 1. So we get undefined for 90 degrees, and then 1 for 45. Okay, now the sine and the tangent both of 180 degrees. So 180, the sine is 0, the tangent is also 0. So they're both zeros. Okay, now we're going to switch to the radians, but we still treat it the same way. So cosine of pi thirds, go to pi thirds right here, cosine 1/2. Okay, so pretty simple stuff here, isn't it? Okay, now 7 pi 6 and 5 pi 6. Well, we may have to do these ones one at a time. So 7 pi sixths, so 7 pi sixths, and we wanted cosine. And then 5 pi sixths, I believe, we wanted, so tangent would be negative square root of 3 over 3. Cosine of 7 pi sixths, negative square root of 3 over 2. So this was negative square root of 3 over 2, and this was negative square root of 3 over 3. Okay, now 3 pi fourths, the tangent. So 3 pi fourths is right here. The tangent is negative 1, I believe. Yep, negative 1. And then we also wanted the tangent of 11 pi over 6, which is negative square root of 3 over 3. So negative 1, negative square root of 3 over 3. Okay, now 4 pi thirds and just pi thirds, sine and cosine. So 4 pi thirds and pi thirds, the sine and the cosine. So sine, negative square root of 3 over 2, cosine 1/2. So negative square root of 3 over 2 and 1/2. Okay, now sine of pi halves, which would be 90 degrees, which I could tell you right now is going to be 0, but we'll double check that. And 7 pi fourths. So 7 pi fourths right here, sine is negative square root of 2 over 2, and of pi halves was 1. Oops, got that one wrong. I was thinking cosine. That's why it's best to double check. And then we had the negative square root of 2 over 2. Okay, and that's all there is to those ones, guys. Just using that information. Okay, now I'm going to take a look at, we're going to skip those ones. I'll come back to them at the end, but we're going to talk about graphing. So remember, for cosine, the parent function, okay, the amplitude is 1, the period is 2 pi, and the midline shift is 0. So my midline starts here. I start up at my amplitude. I also end at my period and my amplitude. In between, I go below my amplitude. Then in between the first and the half and the last, we hit the midline. There's our parent graph. So how's ours different? Okay, so they have a negative 2 plus here, which means that's our k, is negative 2. Nothing in front of the cosine, so amplitude of 1. Nothing right here, no b, so period of 2 pi. So basically the whole thing just shifts down 2. So here's where we start. Amplitude up 1. We end at the same place. In between we go below 1. Then in between, and in between. And there we go. Okay. Now for the sine, remember the sine has these same amplitude, period, midline. Difference is the sine starts on the midline. Oops, that was a little off. Ends on the midline at the period. Halfway in between it's on the midline, kind of opposite the cosine. Then halfway between the first and the middle, we go up 1. Halfway between the middle and the last, we go down 1. And there's the sine. Now our new one has no plus, has no b, so period of 2 pi, midline of 0. Its amplitude, however, is going to be 4. So it doesn't affect its starting, it's still on the midline. It's ending at 2 pi on the midline. And the middle is still on the midline. But this first one, instead of going up 1, we go up 4. And then between the middle and the last, instead of going down 1, we go down 4. So there's our new one. Okay? So, sine of pi over 2. So, amplitude of 1, because there's nothing out front here. Midline of 0. So start here. Okay? Now a b of 1/2. And remember, to find the period, it's 2 pi divided by b. Or 360 if we were doing degrees divided by b. So that ends up being 2 pi times 2 over 1. So our period ends up being 4 pi. Okay, so I start midline on the y-axis right here. I end, instead of 2 pi, I stretch it out to 4 pi. Then I go halfway between 0 and 4 pi is 2 pi. Halfway between that, up pi, I go up 1. Halfway between 2 pi and 4 pi, I go down 1. So at 3 pi. And there's my new function. Okay? All right. Now cosine. So amplitude now is 1/2. Period. We've got 2 here, so I go 2 pi divided by 2, which is just pi, so a period of pi, and then a midline of 1. So I go up 1 for my midline. Instead of starting up above that 1, I start up 1/2 because of my amplitude. And then I only go to pi for my end at that 1/2. Halfway between those at pi halves, I go down 1/2. Halfway between the first and the middle, on the midline, between the middle and the last, on the midline, and there's my cosine. Now, let's work it backwards. All right, so we want to write the equation, which means we need the amplitude, the period, and the midline. Okay, so let's find those first. Typically, the midline is the easiest one to find. So if we look at this, we should see the midline's at -1. Okay, which would mean our amplitude is up at 2, or down 2, so it's 2. The period, we start here, we go until we get back to that same point, so it's at 2 pi. Okay, now for the equation, remember, and because we started on the midline, most likely this is going to be the sine function. Okay, so the sine function is amplitude times sine of b times theta, or x, plus k. Now, for the period, to find the period, it was 2 pi divided by b. So if our period is 2 pi, the only number that b could be is 1. Okay, so b would equal 1. So our equation, y equals 2 times the sine of 1 theta, or just theta, minus 1. Okay, now for 44, let's find that one. So again, look for that midline. So up 5, down 5, so the midline's going to be on the x-axis. So k of 0. Okay, which means we have an amplitude of 5 and a period of, so we start up here. How long does it take us to get back there? Looks like pi. So period of pi, so I go pi equals 2 pi divided by b. Okay, so if I multiplied by b on both sides, I'd get b times pi equals 2 times pi, which should be pretty easy to see what we're going to end up with. You may have seen that from the start. So b equals 2. So now we started above, so most likely this is a cosine. So I'd go y equals a, 5, times cosine of b, 2, times theta, or x, then plus 0, or just leave it like that. Alright, 45. The Ferris wheel at Lagoon has a diameter of 21.8 meters. It rotates on a platform that is 3 meters above the ground. The Ferris wheel completes 1 revolution in 40 seconds. If you get in the Ferris wheel at the bottom at time of 0, what time will you be at the top? Okay, so we're starting out down here, right? Okay, so we want to know, if we start out there, how long until we get to the top, right? Well, it completes a revolution, see, 1 period in 40 seconds. So if we follow that till we get to the highest height right here, it would be 20 seconds. So in 20 seconds. And then if we went around again, it would be at 60 seconds. And again, 100 seconds, and so on. But the quickest we would be there up to the top would be 20 seconds. Alright? Okay, now let's jump back and take a look at these guys. Okay, this is more review from the first part of the benchmark, actually, but I threw it in there just to help us. And this is dealing with the law of sines and cosines. Okay, law of sines, remember, is the side over the sine of the angle equals another side over the sine of its angle and another side. Okay, and we could flip-flop it depending on what we needed. So if we look at 34, okay, and to use the law of sines I need a connection between an angle and a side opposite. So I want to find this side, which would be opposite that angle. So I'm looking for the side xz. I would put it over the sine of 58 degrees, and that's going to equal 25 over the sine of 47. Okay, so then I'm going to multiply by the sine of 58 to get to both sides. So what I need to do is go 25 divided by sine of 47 degrees times the sine of 58 degrees. Okay, use my calculator to figure that out, and I get, so when we put it in our calculator, we get about 28.989. Wants us to round to the nearest tenth, so we'd have to round up to 29. Okay, so that's one way to use the law of sines. Now, the other one we had was the law of cosines, which was the opposite side squared is equal to the other two sides, and I should have made that a small a, squared added together, minus 2 times those two side lengths times the cosine of angle A. So in 35 we see a prime example of that. We want to find this side, and there's no connection like there was on 34, so we can't do the law of sines. So this would be like the A, and that's like B and C. So I'd go A squared equals 19 squared plus 21 squared minus 2 times 19 times 21 times the cosine of 97 degrees. Now, the beautiful thing about this is I could solve it by hand, or I can realize I'm just taking the square root, and so I'm just going to type it into a calculator to save me the trouble. Okay, and when I do that, I end up with the length being 29.98 again. So we just call that 30 if we're rounding up to the nearest tenth, since I have to round from the tenth. Okay, now in 36 is kind of a two-step. We're going to start with that law of cosines to figure out what, call this little b, is. Once we've got that connection, then we can figure out what angle C is using the law of sines. So I start out b squared equals 21 squared plus 12 squared minus 2 times 21 times 12 times the cosine of 110 degrees. Okay, take the square root of all that, type it into my calculator, and we get 27.5205. And I'm going to leave it at that till the very end. So now, if I'm looking for angle C, I go the sine of C over its opposite side, 21, equals the sine of 110 degrees over 27.5205. So I times both sides by 21, okay, and that gives me the sine of C of this whole thing. Well, if I'm going for the sine of C, I have to use the inverse sine of that whole thing, like this, and that'll give me what angle C is, okay? So again, I'm going to use the calculator to help me out with that. So I just type the inverse sine in there, and then I just type everything how I see it. The regular sine of 110 degrees over 27.5205 times 21, all in parentheses. Inverse sine, that gives me angle C of 45.8 degrees. And that's my answer. Okay, 37. Now it just gave us into it in the regular format. Okay, and if I wanted to, I could draw a triangle, label it R, S, T, little r, little s, and then fill in the information. Little s is 12, little r is 21. I'm looking for angle R, and angle T is 138 degrees. So again, this is just like 36. So I'm going to go find T first. T squared equals 12 squared times 21 squared minus 2 times 12 times 21 times the cosine of 138 degrees. end up taking the square root of that whole thing, and that'll give me t. And I get about 30.9765, okay? And that's t. Now that I have that connection, I can go the sine of 138 degrees over that whole 30 thing is equal to 21 here on the bottom, and I'm looking for the sine of angle R. So I times by 21 again. Okay, so again, I'm finding that inverse sine of this whole thing, and that's going to give me angle R. And again, I want to use the calculator to help me out with that. So I do the inverse sine of the sine of 138 degrees over 30.9765 times 21. And that gives me 26.97, so I'll just say 27 degrees for angle R. Okay, so again, another two-step using sine and cosine. Now, the last one here, okay, Juliet is sitting on her balcony gazing lovingly down at Romeo. Romeo has brought a 12-foot ladder so that he can climb to Juliet's balcony and steal a kiss. If Romeo places his ladder, so good idea to draw this, right? Got the balcony, Juliet here, okay, Romeo down here. So he put his ladder 4 feet here, and his ladder's 12 feet here, okay. At what angle should he place the ladder? So in essence, what's that angle? Okay. Now, because we're going to assume that this balcony was built at a 90-degree angle, so we're going to assume that's a 90-degree angle right there. Okay. So, honestly, probably the easiest thing to do here is we can figure out what this is, okay, and then we should be able to use the law of sines to help us with that, or just regular trig, but we'll use the law of sines. So, Pythagorean theorem would be 12 squared, since it's the hypotenuse, equals 4 squared minus question mark squared. 144 equals 16 minus question mark, or plus, minus 16. And that gives me 128. Take the square root of that. Gives me about 11.3137 for that distance right here. Okay, now with that we can use, honestly we can just use, we could have just done this with regular trig, but being that I'm trying to do the sine stuff, we would go the sine of angle, we'll call R for Romeo, over 11.3137 equals the sine of that 90-degree angle over 12. So we times both sides by 12. Oops. We times both sides by 11.3. Not by 12, because we want to get this side. And then we're going to do the inverse of that sine of 90 degrees over 12 times 11.3137. Okay, and that's going to give us angle R. So, type it into my calculator, the inverse sine of 90 degrees over 12 times that by 11.3137, and that gives me about an angle measure of about 70.5 degrees. So that's about the angle measure you will need to put it to make it work. Alright, so there we go, guys. Make sure you're ready for that rest of that test, and we are done.